We're going to finish up chapter 10 notes today. There's not much left. There's only just this little part of this page. But then I've added another example down at the bottom that I want to cover that's pretty important that we kind of breezed over a couple of days ago. But first of all, the instructions for these last 6 problems are to solve for the variable in the following problems. Well, sometimes the variable is theta, and sometimes the variable is x. But we have to solve for that, which means we have to say what theta is equal to or what x is equal to in the end. And our little reminder here is that when two cofunctions are equal to each other, which is the case in all of these problems, the angles that come after those cofunctions are going to be complementary. And remember, complementary means they add to 90 degrees. So you should add that into your notes. So when we get an equation like this, if we see that a tangent of something is equal to a cotangent of something, well, tangent and cotangent, we learned before, are cofunctions. Tan, cotan. So because those two are cofunctions of each other, what that means is the angles that are after these cofunctions add to 90 degrees because they're complementary. And so how we would set this up is don't ever set theta equal to 5 theta. That's what a lot of people do. They just think the angles are equal to each other. Please don't do that. All you have to do is add up those angles, in this case theta plus 5 theta, and set it equal to 90 degrees, and then you'll find theta. Well, theta plus 5 theta is 6 theta. It's just like an x. 6 theta is equal to 90 degrees. And so now we just do 90 divided by 6, which is 15. So theta is equal to 15. And that's the end of that problem. And if you wanted to check it out, we could see if the tangent of 15 degrees is equal to the cotangent of 5 times 15, which is 75. See if the tangent of 15 equals cotangent of 75. Then we'd know it would work. Let's just check that out. Let's see if the tangent of 15, which is that, is equal to the cotangent, which is 1 over the tangent of 5 theta, which is 15. 5 times 15. And they're exactly the same. So the tangent of 15 is equal to 1 over 5, or the cotangent of 5 theta, if theta is 15. These aren't identities. Remember, these are equations that are only true when theta is 15. In this example, secant and cosecant. Secant, cosecant. Well, we know they're cofunctions, which must mean that these angles, x and x plus 60, what do? They add up to 90. So we just say x plus 60 add up to 90 because they're complementary. So what we get is x plus x is 2x. Whoops, 2x. Subtract 60 from each side to save ourselves a little room. So 2x is equal to 30. And divide each side by 2, x equals 15. And the secant of 15 should equal the cosecant of 15 plus 60, which is 75. And that should work because 15 and 75 are complementary. Okay, here we go with sine and cosine. Sine and cosine are cofunctions. So that must mean that 2x and x plus 15 add up to 90. So you know what you might want to do is just shut the video off now. All the rest of these are exactly the same. See if you can solve these for either x or theta, whatever the variables are. Then turn it on and make sure that you're right. So 3x equals 75, so x equals 25. And does the sine of 2 times 25, which is 50, equal the cosine of 40? Well, 50 and 40 are complementary, so that must be right. Cosine and sine are cofunctions, which means theta plus 2 theta plus 15 must add up to 90. So 3 theta is equal to 90 minus 15 is 75. Theta must be equal to 25. Tangent and cotangent are cofunctions. So theta plus 5 added to 2 theta minus 20 should equal 90. Oop, I've given myself not much room here. Let's see, theta plus 2 theta is 3 theta. And 90 plus 20 is 110. And 110 minus 5 is 105. So 3 theta is equal to 105. So what's 105 divided by 3? Oops. 105 divided by 3 is 35. So theta is 35 here. And this next example, x plus 8 plus 90 minus 2x add up to 90. See, x minus 2x is negative x plus 98 equals 90. So if you subtract 98 from each side, you get negative x equals negative 8, so x must be equal to 8. So let's see, 8 and 8 is 16. 90 minus 16, let's see, that is 74. So 74 and 16, yep, that adds up to 90. So those are correct. Now the only other thing, since this video is only 6 minutes long so far, the only other thing I want to show you is this could come up on a Regents exam sometime, maybe this June. I'm going to start you off with this Pythagorean identity that we learned, sine squared. There's a Pythagorean identity way back on page 4 of your notes, if you remember that, this Pythagorean theorem, or the Pythagorean identity. Cosine squared of an angle plus sine squared of a same angle is equal to 1. Well, what I'm starting you off with is that Pythagorean identity. I'm just using a's instead of thetas. So if the sine squared of a plus the cosine squared of a equals 1, I want you to derive, which means come up with. If you see the word derive, it just means come up with. Maybe you can hear that singing above me up in the choir room. So what we're going to do, I showed you how to do this before on that other sheet, but what we're going to do is we're going to divide each term by sine squared of a. So what this becomes is, we'll start out with sine squared of a plus cosine squared of a equals 1. And if we divide every term by sine squared of a, what we have is sine squared over sine squared. Anything over itself is equal to 1. Cosine over sine is cotangent. So cosine squared over sine squared is cotangent squared of a. And since 1 over sine is cosecant, 1 over sine squared is cosecant squared of a. So there's the first one that you have just derived. And the next one I want you to derive is, instead of dividing everything by sine squared, we're going to divide by cosine squared. So we'll start out with sine squared of a plus cosine squared of a equals 1. That's always true no matter what you put in for a. Now instead of dividing by sine squared, let's divide everything by cosine squared. You can divide by anything you want, but this is a good thing to divide by. Well, sine over cosine is tangent, so sine squared over cosine squared is tangent squared. Cosine over cosine is 1. Cosine squared over cosine squared is 1. And then 1 over cosine squared is the same thing as the secant squared. So we have just derived these are two other Pythagorean identities, but they all come from this most important one that is used all the time in trig, that the sine squared of an angle plus the cosine squared is always equal to 1, no matter what a is. And that's the end of today's short video.